In this video, we'll be going through the 2025 specimen paper for H2 Math revised syllabus 9758. This is paper 2. So for paper 2, the first part or the first 40 marks will be on pure math and the next 60% will be on statistics and probability. So in this video, we'll be doing part 1, which is your section A on pure math. So let's take a look at this question. Question 1, the function f is defined as this. Fx equals to x squared plus 6x minus 10, where x is real. By using the method of completing the square, find the range of f. So we need to complete the square to find the values or the range of values of f. Fx equals to x squared plus 6x minus 10. X squared plus 6x minus 10. Now to complete the square, it will become x plus 3 square minus 10 minus 3 square, which gives me x plus 3 square minus 19. So based on this, okay, we will be able to find what is the range of values of f. Range of values of f is, so because the coefficient of x squared is positive, we know that this is how the quadratic curve looks like. So it has a minimum point, and the minimum value of f is negative 19. Okay, and the maximum value, it can go to any value all the way to infinity. So the range of values of f is from minus 19 to infinity. Completing the square is part of the additional math that we have done in additional math and also e-math in secondary school. So I talked more about how to complete the square in this blog post here. There is also a complete the square calculator where you can put in the coefficients of a, b, and c in the quadratic equation, and then it gives the completed the square form. So like for example, for this question here, we are doing x squared plus 6x minus 10. So therefore, I put in a equals to 1, b equals to 6, and c equals to minus 10. Okay, then just click solve. Okay, you will be able to get the completed the square form is minimum point, which is as minus 3 minus 19, as well as the minimum value of y, which is minus 19. Can play around. So if you have the a value as negative 1, then instead of having minimum point and minimum value, you should have a maximum point as well as a maximum value, and the calculator will be able to calculate that. Okay, so do check it out if you are interested. I'll provide a link in the description below. So now let's go on to the second part, sketch the graph of f. So we know that this is a quadratic curve, okay, with a minimum point at minus 3 minus 19, right? Okay, so we know that the minimum point is minus 3 minus 19. You can also use the GC to look at where it crosses the x and the y axis as well. All right, okay, so based on this, we have a curve that looks something like this. So this is minus 3 minus 19, okay, and it should look something like this. Okay, and we know that when x is 0, it is minus 10. All right. Okay, so we have sketched the graph of f. Okay. Next portion, the function g is defined as follows. Gx equals to x squared plus 6x minus 10, where x is lesser than or equals to alpha. So basically they take the same rule. G and f take the same rule. The only difference lies in their domain. Okay, you are given that the function g inverse exists, so state the largest possible value of alpha, explaining why this is the largest value. So well, in order for the inverse of a function to exist, the function must be a 1-1 function. So the largest value that alpha can take, right, must be minus 3, because from here to from minus 3 all the way to negative infinity, or from negative infinity all the way until negative 3, you have a 1, 1 function, right? This portion here is a 1, 1 function. Okay, then this portion here is another 1, 1 function, or anything, any subset of this green portion is a 1, 1 function. So because we know that for gx, okay, its domain is x lesser than or equals to a, so therefore we know that a must be minus 3. So you just need to state, you just need to say largest a okay, then you need to explain, right? You need to explain why this is the largest value. Okay, so okay, because from minus infinity to minus 3, g is a 1, 1 function. Okay, if you go anything more than negative 3, okay, you'll start having some values of y that have 2x values, right? So therefore, the largest value a can take is negative 3. Next, you are asked in part B, part 2, to find an expression for g inverse x. So we will let y be equals to gx first. So we know that y is equals to x squared plus 6x minus 10, right? But when you have x squared and x, okay, so before I do say that, in order to find the inverse, you need to make x the subject, right? But if you have x squared and x, in order to make, you can't really make x the subject. And the only way to do so is by completing the square, so that now you only have x here. It's not spread between two different terms with different powers of x. So therefore, we will use the completed the square form. Okay, and I also want to write in that x is smaller than or equals to minus 3. So now I need to make x the subject, right? So I know that x is equals to plus minus square root y plus 19 minus 3. And because x is lesser than or equals to minus 3, I need to reject minus 3 plus square root of y plus 19, because this will be positive. Negative 3 plus a positive number will be more than negative 3, which is not what we want. So therefore, I know that x is equals to negative square root y plus 19 minus 13. And my g inverse x is negative square root x plus 19 minus 3. Okay, and before I end this off, they want a similar an expression, right? So because in this expression here, they gave us the domain of g. So when you write an expression for g inverse x, you must also give the domain. And we know that the domain of g inverse is equals to the range of g. And since g is this yellow portion of the curve, and we know that the range of g is from negative 19 all the way to infinity, so therefore the domain of g is x greater than or equals to negative 19. Let's go through question 2 together. Question 2 is a system of linear equations type of question. So in question 2, you're given that the first 4 terms of the sequence of numbers are 4, 2, 2, and 4. The sum of the first n terms of the sequence is Sn. Explain why Sn cannot be a quadratic polynomial in n. So we know that 4 is the first term, 2 is the second term, and so on. Okay, and to find the sum of the first n terms, so S1 is simply the first term. Okay, S2 is the sum of the first 2 terms, so it's 4 plus 2 equals to 6, and so on. So we can form 4 equations, okay, in terms of a polynomial, a quadratic polynomial. Okay, and then we will try to solve it. But when you have a quadratic polynomial, so for example, if you have a quadratic polynomial, let me use e n squared plus fn plus g. Okay, 3 unknowns only, right? E, f, and g. But you have 4 equations.
Okay, so what this means is that, right, you only need to use 3 of the equations to solve for the 3 unknowns, and then for the 4th equation, you check to see whether for these values of E, F, and G that you have obtained, okay, do they satisfy the 4th equation or not? If it's satisfied, that means that Sn can be a quadratic polynomial in N. Okay, so let's do this together. You notice why I use E, F, and G is because for the next part I use A, B, C, D. So if I use A, B, C again, this A and this A will not be the same because this is quadratic, this is cubic, right? So that's why I use E, F, and G. Okay, so now let's do it. So I will let Sn be equals to En squared plus Fn plus G, where E, F, and G are constants. Okay, so now I know that S1 is equals to the sum of the first term. The first term is equals to the first term, right? So it's equals to 4. And I'm going to write 4 is equals to, I'm going to sub n equals to 1 into this equation, so I get E plus F plus G, and that's equation 1. So S2 is equals to 4 plus 2, which is 6, and I know that 6 can also be, I'm going to form this equation for S2, so I'm going to sub in n equals to 2, which is 4E plus 2F plus G. Next, S3 is basically S2 plus the third term, so 6 plus 2, which is 8, so I know that 8 is equals to, sub in n equals to 3 into this equation here, so it's 9E plus 3F plus G. Then do the same for S4, I know S4 is 8 plus the fourth term, which is 4. So it's 12. So 12 is equals to 16E plus 4F plus G. Okay, so solve 2, 3, and 4 with GC. You can also select 1, 2, and 3. You'll get different E, F, and G values. Okay, because the same E, F, and G values cannot be used to satisfy all 4 equations. Okay, so you have E equals to 1, F equals to minus 3, and G equals to 8. Okay, then I'm going to sub E equals to 1, F equals to minus 3, G equals to 8 into equation 1. Okay, so I have right hand side, which is here, is equals to E, F, G, which is 1 minus 3 plus 8, which is 6, and it is not equals to 4. So since the right hand side is not equals to the left hand side for 1, so therefore we know that Sn is not or cannot be a quadratic polynomial. Okay, now moving on to part B. Okay, so now we are given that Sn equals to an cubed plus bn squared plus cn plus d, and we are asked to find the values of a, b, c, and d. So basically it's very similar to a. Sub in n equals to sub in n equals to 1, okay, then form an equation. Then after that you use your GC, poly simultaneous, okay, to solve for a, b, c, and d. So now we have Sn equals to an cubed plus bn squared plus cn plus d. So we know S1 is 4, right? So we know 4 equals to sub n equals to 1 in is a plus b plus c plus d. Then do the same for your S2, S3, and S4. Alright, so you have 6 is equals to 8a plus 4b plus 2c plus d. Then 8 equals to 27a plus 9b plus 3c plus d. And then 12 equals to 64a plus 16b plus 4c plus d. Then by GC, we know that a is equals to 1/3, b equals to minus 2, c equals to 17 over 3, and d equals to 0. So we have found the values of a, b, c, and d. Next, you're asked to find an expression in terms of n for the nth term of the sequence. So from part 2b, we know that Sn is equals to 1/3 n cubed minus 2n squared plus 17 over 3n. So we want to find the nth term, right? Nth term. So to find the nth term is basically equals to sum of the first n terms minus the sum of the first n minus 1 term. Okay, so this is equals to 1/3 n cubed minus 2n squared plus 17 over 3n. Okay, minus, you just replace n with n minus 1 here to find the n minus 1 term. Okay, so after this, what we need to do is we need to do an expansion, right? So I'll expand this. So this is n minus 1 and n minus 1 square, right? N minus 1 square is basically n square minus 2n plus 1. Okay, then I'll change this to plus 2n minus 1 square, then plus 17 over 3n minus 1. Okay, so basically you just continue with the expansion, okay? And you will get an answer of n squared minus 5n plus 8. So this is the nth term of this series. Okay, let's move on to question 3. In question 3, we are given that the angle between these two vectors is cosine inverse 6 over 13. Find the possible values of d. Okay, so this is a vector question, and basically in part A, you asked for the angle between two vectors. So we know that to find angle between vector v and w, okay, if theta is the angle between v and w, then cosine theta is equals to v dot w over mod v mod w, right? So same thing now, your v is like 3 minus 2, and your w is 6d minus root 7. Okay, so from there we want to find what is d. Okay, so let's do it. So this is a very quite straightforward question, so just need to be careful during the exam. Okay, so I will put the cosine inverse here, since this is what the question writes. 3 minus 2 is 0 dot 6d root 7. So simplifying it, and we know that this is equals to cosine inverse, how much is this? Cosine inverse 6 over 13. Right, 6 over 13. Yep. So in other words, I can say that this okay, with that, let's solve. So cross multiply. Okay, let me simplify before I square both sides. So 13 is equals to root 13 times root 13, right? So I can rewrite this as root 13 times root 13. So I can cancel this root 13 and this root 13, right? And then everything I can divide by 2 because, okay, so I'm left with this. Then I'm going to take out the 2. Okay, the reason why I want to simplify it so much is because later I'm going to square both sides. I don't want too big a number. It's easier to handle smaller numbers. Okay, so I'm left with this. Okay, now I'm going to square both sides. Okay, so square both sides. Square 3, I get 9. Square this with a square root, I just get whatever without the square root. And then I have 9 minus d squared. Okay, then now I can solve it. I can solve it. So they did not ask whether, they did not say that without using the calculator, neither did they say that they want exact values. So in fact, once we reach this point here, you can simply just type it into your GC, use the graph, equate one side to this and the other side to here, you can solve it. So in fact, you can use by GC. Okay, and you'll get your D equals to 3 or 55.5. Okay, but you need to be able to see the other portion here. Okay. Okay, so possible values, so we need the two values. Okay, so it's 3 or 55.5. Okay, if you want to expand, you can also do so. You can slowly expand. Okay. And it will, when you expand, you end up having this, you also get the solution D equals to 3 or 55.5. So both will give you the same answer, but I would recommend please use this method by GC. Okay? Reason, they didn't say cannot use GC. So if they did not say without using the GC, they did not say they want exact values, please use your GC. Alright? Okay, I think another thing to note, right, when solving it by GC, so you're probably going to use the graph to solve by GC to look for the point of intersection between this curve here and 6 over 13, or you're going to equate everything, put everything to one side and equals to 0 and then look for the x-intercept. Doesn't matter what it is, there's a rather big value here, but what you need to know from here is that it's likely to be a quadratic function. Okay, it's likely to be a quadratic equation after you square it. Okay, and so you're likely to have two solutions, so you need to find them. Another clue, right, for A level, you notice that whenever they say possible values with an S, okay, that means you have more than one answer. Right? Okay, so now moving on to part B. So with reference to the origin O, points A, B, and C are such that OA is equals to A, OB equals to B, AC equals to 5A. Okay, so here's 5A. Okay, BD, which is here, is 3B. So this vector in this direction is 3B. So that means OD is 4B. Okay, AC is 5A. So OC, which is OA plus AC, is 6A. Okay, we're supposed to find OE. So how do I do? So I know that E is the point of intersection between BC and AD, right? So I'll find an equation for line BC and find equation of line AD, then solve for point of intersection. Okay, so let's do it. Okay, so now let's find equation of BC. So to find equation of line, basically you will have a point, right? So OB is a point on the line, so I'll just write it as B. Then plus, maybe let me use T, BC, right? And I know BC is OC minus OB. Hey, wait, did they give me BC? Let me check. Oh, they already give me BC, which is, no, they did not. Okay. Okay, so remember, recall I wrote OC is 6A, OD is 4B. Let me first write them here. So BC is OC, which is 6A, minus OB, which is B. So it's 6A minus B. Okay, next I need to find equation of line AD. So again, R equals to a point, a position vector on the line. Then maybe I'll use K as the constant. Then I need AD, right? I know AD is OD minus OA, so OD is 4B. Okay, so this is AD. And K is real. So E is the point of intersection between BC and AD, right? So at E, these two are equal to each other. Okay, so next I'm going to put all the vectors with A on one side and all the vectors with B on another side. Okay. So B, this is B, and I have a minus TB, and also I have a minus 4KB. Next, I'm going to put all the vectors with A on this side.
So 1 minus t minus 4kb is equals to 1 minus k minus 6ta. Okay, so now let's take a look. Is vector a and b parallel? No. Okay, vector a and b, they are non-parallel, they are non-zero. So in order for two non-parallel vectors to be equal to each other, these two constants must be 0, because there's no way b and a can be equal to each other because they are not parallel. Okay, so since a and b are not parallel and non-zero, so therefore this is equals to 0 as well as this is equals to 0. So make it nice for your GC, so it'll be t plus 4k equals to 1. Then 6t plus k equals to 1. So by GC, okay, use your poly simultaneous, or you can just use your scientific calculator to solve for t and k. So I have t equals to 3 over 23 and k equals to negative 5 over 23. So now I need to find OE, right? So OE, you can simply use either the equation for BC and then sub in T, or equation of line AD and sub in K. So I will use this one. Okay, so OE equals to A, okay, minus 5 over 23 4B minus A. Then simplify it, you'll get 18 over 23A plus 20 over 23b. Right? Okay, now the point F on CD is such that CF is to FD is 5 is to 3. So we know that F lies on the line CD, right? So let me join it here. Okay. Okay, and I also know that OE and F are collinear. All right. So this is point F. Okay. So I need to show that OE and F are collinear, and I need to find the ratio of OE is to EF. Okay, and I also know that CF is to FD is 5 is to 3. All right. Okay, so let's find OF. So by ratio theorem, we can find OF, right? So by ratio theorem, OF is equals to 3 OC plus 5 OD over 3 plus 5, which is 8. Okay, so you can first find OF, then after that we try to show that OE and OF, they are collinear. Okay, so let's write our answers here. So OF is equals to 3 OC plus 5 OD over 8, okay, which is OC is 6A, right? So 3 times 6 is 18A plus OD is 4, so 5 times 4 is 20. B over 8. Let's simplify it. So 18 over 8 is 9 over 4. Then 20 over 8 is 5 over 2 as the simplest form. So this is OF. Okay. Then let's look at OE. I have also 18 over 20. Wait. Maybe I will keep it as this. Let me just keep it as this, okay? For a moment. So OE is 18A plus 20B over 23, right? Notice? Right, so I can actually write it as this. Or if you don't like it, you can write it as 1/4 9A plus 10B. Okay, Okay, moving on to 4C. So 4C is a long question. Let's take a look at what it asks for. So you're given that the first two non-zero terms in the Maclaurin series for tangent e to the power of x minus 1 are twice as big as the first two non-zero terms in the series expansion of this. So we know that because the first two terms of this Maclaurin series is twice as big as the first two terms of the Maclaurin expansion of this. In other words, right, we know that Maclaurin expansion of e to the power of ax ln 1 plus nx is the first two terms is basically half x plus 1/4 x squared, right? Because the first two terms of this expansion is twice as big as the first two terms of this expansion here. Okay, so this is what we are given. Next, what else? Okay, so by using appropriate expansion from the list of formulas, so one look at this, they ask you to use appropriate expansion from the list of formulas. It means use these formulas here. So you have e to the power of ax and you have ln 1 plus nx. So you're going to use these two expansions here. Okay, these two expansion. It's just that for this, instead of x, you have ax. For here, instead of x, here you have nx. So you're going to replace the x here in this expansion with ax and the x here in this expansion with nx. Okay. Okay, so by using appropriate expansion from the list of formula, find the constants a and n. Okay, so we know that we need to expand this using the standard series expansion and then equate them to half x plus 1/4 x squared. Okay. Next, hence find the third non-zero terms of the series expansion of this. So I need the third term of the expansion. Okay, so I know that the first two terms are x and x squared, so probably the third term is x cubed. So what I'll do is I'll expand everything until x cubed so that I can answer the entire of this question. Okay, so in other words, I need to find what is kx cubed. All right, okay, so now let's do it. So I have e to the power of ax here. So if I want to find the Maclaurin expansion of e to the power of ax, I'm going to use this. And I'm going to replace all the x with ax, right? And because I need terms all the way to x cubed, I'm going to do until the x cubed term. So I'll have 1 plus ax plus ax squared over 2 factorial plus ax cubed over 3 factorial. Okay, so let me write it here. So expand e to the power of ax, I'll have 1 plus ax plus ax whole thing squared. So it's a squared x squared over 2. Then I need to plus, what is the third term? A cube x cube over 3 factorial. 3 factorial is 6 if you use your calculator. A cube x cube 3 factorial, which is 6. Okay, then next I need to expand ln 1 plus nx. So same thing, I'm going to use this expression and then I'm going to expand until the x cubed term. So if I have ln 1 plus nx, I replace all the x with nx, right? So it's equal to nx minus nx whole thing squared over 2 plus nx whole thing cubed over 3, right? Okay, so let's do it. So I have nx minus n squared x squared over 2 plus n cubed x cubed over 3 plus ... Okay, next I want to find terms containing x. So in order to obtain terms containing x, I'll take 1 times nx. Okay, so I have nx. So from here, I know that n is basically equals to half, right? Okay, but let's do that later. So next, I need terms containing x squared. So in order to obtain terms of containing x squared, when I expand these two terms, or when I expand this expression, I would need to take ax times nx, so you give me anx squared. And also, when I take negative n squared x squared over 2 times 1. Okay, I'll put the x squared outside, okay, because both of them have x squared. Next, I need terms containing x cubed, right? So in order to get terms containing x cubed, I'll take 1 times n cubed x cubed over 3. So let me put the x cubed outside again. So it's n cubed over 3. Then to get x squared, I can also take ax times negative n squared x squared over 2. So it give me negative an squared over 2. Then also to get x cubed, I can take this term multiplied by this term here, which will give me a squared n over 2x cubed. Okay, so now I know that n is equals to half, and then I know that an minus n squared over 2 equals to 1/4, and I will sub in x equals to half, so I have half a minus half square, which is 1/4, over 2, so it's 1/8, is equals to 1/4. So therefore I know that my a is equals to 3/4. So now that I've already found n, which is half, and a equals to 3/4, to find the third term, okay, because they asked for the third non-zero term. So let me write third non-zero term. Okay, I'll simply sub in my n and my a into this expression here. Okay, so n is half, so it's half cubed over 3 minus 3/4 half square over 2 plus a, which is 3/4, then square half over 2 x cubed. Okay, I'm going to type this whole thing into the calculator. Okay, and it will give me 17 over 192 x cubed. Okay, so the third non-zero term is 17 over 192 x cubed. So what I'll do is I'll just put in, so I want to write it in terms of OE in terms of OF, right? So I'll put in this. So once I put in the 1 over 4, I need to times 4 over 1, right? So that it will cancel off, right? 4 over 1 times 1 over 4 is 1 over 4. So you notice this is still equals to this, because 4 over 1 times 1 over 4 is 1. Okay, but I know that this is OF. So I can write it as OE is equals to 8 over 23 OF. So we know that OE is equals to 8 over 23 OF. So therefore, since OE and F are parallel with common point O, so therefore OE and F are collinear. Okay, and we are also asked for the ratio of OE is to OF, right? So based on this, we know that OE is to OF is 8 is to 23. Question 4 is a Maclaurin series question. So in this question, 4a part 1, you're given that y equals to tangent e to the power of x minus 1. Show that dy dx equals to k e to the power of x 1 plus y squared, where k is a constant to be found. So what we need to do, we need to differentiate this equation. Okay, so let's do it. So we have y equals y. Okay, y equals to tangent e to the power of x minus 1. So dy dx will be equals to, let's first differentiate this, e to the power of x minus 1, which will give us e to the power of x. Then when we differentiate tangent, we get secant square, and there will not be any change in this angle here, so it still remains as e to the power of x minus 1. Okay, but the question did not want us to leave it as e to the power of x secant square e to the power of x minus 1. Instead, it wants us to leave it in the form k e to the power of x y squared plus 1, right? Okay, where k is a constant to be found. So we do not want this portion here. So we need to change it to y squared plus 1, right? So we need to make use of identities. So from A math, we know that secant square A equals to tangent square A plus 1, right? So I'm going to change this secant square to tangent square plus 1. Okay? And I know that tangent e to the power of x minus 1 is y. So tangent square e to the power of x minus y, sorry, e to the power of x minus 1 is y square. So if I compare it to k e to the power of x 1 plus y square, I know that therefore k is equals to 1. Okay, so this is my answer for 4a part 1. Next, let's move on to part 2. So in part 2, we are asked to find the values of dy dx, d square y dx square, and d cube y dx cube, where x is 0. So let's do it. Alright, so we have already found dy dx. So what we need to do is to differentiate dy dx to find an expression for d square y dx square. So let's do it. D square y dx square is equals to, I need to use product rule for this. So I'll keep e to the power of x, then differentiate 1 plus y square, which give me 2y dy dx. Then I'll differentiate e to the power of x, which is still e to the power of x. Then I just copy 1 plus y square. Okay, and notice e to the power of x 1 plus y square is the same as dy dx, right? This is the same as dy dx. So I'll change this to dy dx because it's easier to differentiate dy dx as compared to e to the power of x 1 plus y square. Okay, so this is what I'm going to do. So I'll write this as 2y e to the power of x dy dx plus dy dx. Okay, anything else I can simplify? Not for now, right? Okay, so next let's do this. I need to differentiate it, this expression again, to find d cube y dx cube, right? Okay, so let's do it. Okay, so let's differentiate this e to the power of x 2y dy dx. So let's differentiate, let's use product rule for these two portions. So differentiate e to the power of x, I get e to the power of x, then I copy this 2y dy dx. Next, I copy e to the power of x, then I need to differentiate 2y dy dx. So again, another product rule. So differentiate 2y dy dx. So I will keep 2y first, then differentiate dy dx. Then next, I will keep dy dx. Then differentiate 2y, which give me 2 dy dx. Okay, then I'll differentiate dy dx, which give me d square y dx square. Let me simplify the expression for d cube y dx cube, which will give me 2e to the power of x y dy dx plus 2e to the power of x d square y dx square. Oh, okay, there's no y here, so I can't add them together. Okay, then next here is 2e to the power of x dy dx square, then finally plus d square y dx square. Okay, so now I need to find the values of dy dx, d square y dx square, and d cube y dx cube when x equals to 0. Okay, so let's sub it in. So when x is 0, let's first find y. So this is an expression for y. So y is equals to tangent e to the power of 0 minus 1. E to the power of 0 is 1. 1 minus 1 is 0. So tangent 0 is 0. Okay. So let's find dy dx. It will be equals to this. So it's e to the power of 0. 1 plus, when x is 0, y is 0. So I put in 0. So give me 1. Okay. Then moving on, let's find d square y dx square. Okay, which is here. So I'm going to sub in my x equals to 0, y equals to 0, and dy dx equals to 1 into this expression. So because y is 0, this whole thing will be 0, and I sub in y equals to 0. So I'll be left with dy dx, which is 1. Then next, let's move on to d cube y dx cube. Okay, so when x is 0, okay, y is also 0. So any term with y will also be 0. So this is gone. So I'll only be left with these 3 terms. Wait, I miss out my y here. So let me put in the y here. Okay, so these 2 terms will be gone because they have y in them. Right, 0 and 0. So I just need to set in x equals to 0 and dy dx equals to 1 here. So I get 3. Okay. So I've obtained the answer for dy dx, which is 1, d square y dx square, which is equals to 1, and d cube y dx cube, which is equals to 3 when x is equals to 0. Alright, let's move on to the next part. So I'm asked to write down the first 3 non-zero terms in the Maclaurin series for tangent e to the power of x minus 1. So I've already found these values here. So Maclaurin series for tangent e to the power of x minus 1. Okay, what to do? Just go to your formula list and make use of this, right? I already found that when x is 0, f0 or my y is 0, then this f prime 0, which is the value of dy dx when x is 0 is 1. Then this is the value of d square y dx square when x is 0, which is also 1. Then I need until x cubed, right? Because they want the first 3 non-zero terms. Right? 3 non-zero terms. So I only have 2 terms till now because this one is 0, so it's not considered. So I also need the x cubed term, which is x cubed over 3 factorial f3 0. And we know that the d cube y dx cube when x equals to 0 is 3, right? Okay, so let's write that in. Okay, so we have 0 plus 1x, then plus 1 over 2 factorial, plus 1 over 2 factorial x squared, then plus 3 over 3 factorial x cubed. Okay, simplify, you will get x plus half x squared plus half x cubed. Alright. Okay, with that, let's move on to 4C. Okay, moving on to 4C. So 4C is a long question. Let's take a look at what it asks for. So you're given that the first 2 non-zero terms in the Maclaurin series for tangent e to the power of x minus 1 are twice as big as the first 2 non-zero terms in the series expansion of this. So we know that because the first 2 terms of this Maclaurin series is twice as big as the first 2 terms of the Maclaurin expansion of this. In other words, right, we know that Maclaurin expansion of e to the power of ax ln 1 plus nx is the first 2 terms is basically half x plus 1/4 x squared, right? because the first two terms of this expansion is twice as big as the first two terms of this expansion here. Okay, so this is what we are given. Next, what else? Okay, so by using appropriate expansion from the list of formulas, so one look at this, they ask you to use appropriate expansion from the list of formulas. It means use these formulas here. So you have e to the power of ax and you have ln 1 plus nx. So you're going to use these two expansions here. Okay, these two expansion. It's just that for this, instead of x, you have ax. For here, instead of x, here you have nx. So you're going to replace the x here in this expansion with ax and the x here in this expansion with nx. Okay. Okay, so by using appropriate expansion from the list of formula, find the constants a and n. Okay, so we know that we need to expand this using the standard series expansion and then equate them to half x plus 1/4 x squared. Okay, next, hence find the third non-zero terms of the series expansion of this. So I need the third term of the expansion. Okay, so I know that the first two terms are x and x squared, so probably the third term is x cubed. So what I'll do is I'll expand everything until x cubed so that I can answer the entire of this question. Okay, so in other words, I need to find what is kx cubed. All right, okay, so now let's do it. So I have e to the power of ax here. So if I want to find the Maclaurin expansion of e to the power of ax, I'm going to use this. And I'm going to replace all the x with ax, right? And because I need terms all the way to x cubed, I'm going to do until the x cubed term. So I'll have 1 plus ax plus ax squared over 2 factorial plus ax cubed over 3 factorial. Okay, so let me write it here. So expand e to the power of ax, I'll have 1 plus ax plus ax whole thing squared. So it's a squared x squared over 2. Then I need to plus, what is the third term? A cube x cube over 3 factorial. 3 factorial is 6 if you use your calculator. A cube x cube 3 factorial, which is 6. Okay, then next I need to expand ln 1 plus nx. So same thing, I'm going to use this expression and then I'm going to expand until the x cubed term. So if I have ln 1 plus nx, I replace all the x with nx, right? So it's equal to nx minus nx whole thing squared over 2 plus nx whole thing cubed over 3, right? Okay, so let's do it. So I have nx minus n squared x squared over 2 plus n cube x cube over 3 plus ... Okay, next I want to find terms containing x. So in order to obtain terms containing x, I'll take 1 times nx. Okay, so I have nx. So from here, I know that n is basically equals to half, right? Okay, but let's do that later. So next, I need terms containing x squared. So in order to obtain terms of containing x squared, when I expand these two terms, or when I expand this expression, I would need to take ax times nx. So you give me anx squared. And also, when I take negative n squared x squared over 2 times 1. Okay, I'll put the x squared outside, okay, because both of them have x squared. Next, I need terms containing x cubed, right? So in order to get terms containing x cubed, I'll take 1 times n cubed x cubed over 3. So let me put the x cubed outside again. So it's n cubed over 3. Then to get x squared, I can also take ax times negative n squared x squared over 2. So it give me negative an squared over 2. Then also to get x cubed, I can take this term multiplied by this term here, which will give me a squared n over 2x cubed. Okay, so now I know that n is equals to half, and then I know that an minus n squared over 2 equals to 1/4, and I will sub in x equals to half, so I have half a minus half square, which is 1/4, over 2, so it's 1/8, is equals to 1/4. So therefore I know that my a is equals to 3/4. So now that I've already found n, which is half, and a equals to 3/4, to find the third term, okay, because they asked for the third non-zero term, so let me write third non-zero term. Okay, I'll simply sub in my n and my a into this expression here. Okay, so n is half, so it's half cubed over 3 minus 3/4 half square over 2 plus a, which is 3/4, then square half over 2 x cubed. Okay, I'm going to type this whole thing into the calculator. Okay, and it will give me 17 over 192 x cubed. Okay, so the third non-zero term is 17 over 192 x cubed.
If you like this video, do like and subscribe. For more math resources, visit mathandsg.com.